Hi, welcome back to SQL Database Administration Hub. Today, we're going into SQL Server file architecture. Every database you manage lives in files on disk, and as a DBA, you need to know exactly what those files are, what they do, and how to manage them properly. Let's get started. When you create a database in SQL Server, it doesn't just exist in memory, it's stored in physical files on disk. SQL Server uses a specific file structure to organize your data, and understanding this structure is fundamental to everything from backup planning to disaster recovery. In this video, we'll cover three key areas: the different file types SQL Server uses and how Filegroups work, how to set up a smart autogrowth strategy, and how the transaction log works internally. These are concepts you'll use every single day as a DBA. Every SQL Server database is made up of at least two files.
The first is the MDF file. This stands for Master Data File.
Every database has exactly one MDF file, and it's the primary data file. It stores your actual data, your tables, indexes, stored procedures, and everything else that makes up your database. The second is the LDF file, the log data file, better known as the transaction log. Every database has at least one LDF file. This is where SQL Server records every single change made to the database before that change is applied to the data file. It's the backbone of SQL Servers. Reliability and recovery capabilities. The third file type is the NDF file.
Every database has a primary file group that contains the MDF file.
You can create additional file groups to organize large tables or indexes onto specific disks. For example, you might put a heavily queried index on a faster SSD in its own file group, while keeping historical data on slower storage. File groups give you flexibility and control over how your data is physically stored. By default, SQL Server data files and log files are configured to grow automatically when they run out of space. This sounds convenient, but poorly configured, autogrowth is one of the most common performance problems DBAs encounter. Here's why. When a file needs to grow, SQL Server has to pause and allocate new
Space on disk. This causes a brief but noticeable performance spike.
If it happens frequently, say every few minutes on a busy database, those pauses add up and users feel it. The solution is a smart autogrowth strategy built around two principles. First, pre-size your files. Estimate how large your database will be over the next 6 to 12 months, and set the initial file size to cover that growth. This way, autogrowth events become rare exceptions rather than regular occurrences. Second, set autogrowth in fixed megabytes, not percentages. By default, SQL Server sets data files to grow by 1 megabyte and log files by 10%. Percentage-based growth becomes increasingly problematic as files get larger. A 10% growth on a 100 gigabyte file means allocating 10 gigabytes at once, which causes a significant pause. Instead, set a fixed growth increment that makes sense for your environment. To change autogrowth settings, right-click your database in SSMS, select Properties, go to Files, and adjust the autogrowth settings for each file there. The transaction log is one of the most important and most misunderstood parts of SQL Server. Let's break down how it actually works. The transaction log is a sequential file. SQL Server writes to it from beginning to end in order. It's divided into sections, called virtual log files, or VLFs. SQL Server uses these VLFs in a circular fashion, reusing space once it's no longer needed. Here's the key concept. The transaction log can only reuse space after a log backup has been taken, assuming your database is in full recovery model. This is why databases in full recovery model that never have their log backed up will see their log file grow indefinitely until the disk runs out of space. As a DBA, you must have a regular log backup schedule to keep the log from growing out of control. Another concept to understand is log truncation. Truncation doesn't shrink the log file. It marks space inside the log as reusable. The physical file stays the same size, but the internal space gets recycled. Actual shrinking of the log file is a separate operation and something you should do rarely and carefully, as it can cause fragmentation. Understanding the transaction log is critical for backup strategy, recovery planning, and troubleshooting, all of which we'll cover in depth later in this course. And that's SQL Server file architecture covered. To recap, every database has an MDF primary data file, an LDF transaction log file, and optionally NDF secondary data files, all organized into file groups that give you control over physical storage. You learned why a smart autogrowth strategy using fixed increments and pre-sized files protects your server from performance spikes. And you now understand how the transaction log works internally, writing sequentially, using virtual log files, and requiring regular log backups to recycle space. This knowledge connects directly to everything coming up in this course. Recovery models, backup strategy, and performance tuning all build on what you learned today. Subscribe so you don't miss the next video, and I'll see you there.
Generous Academy.